Hi guys, I hope you are fine. Me too, I'm fine. So today guys, we are going to learn about vectors. So guys, I'm going to read the question and then we attempt to do it. A beam is supported by three forces represented by the vectors. So that is the one of the vector, and then B, that is another vector, and C, that vector. Find the angle between A and C, and then A multiplied by C. The vector we are talking about, guys, are actually three-dimensional. Three-dimensional in that they have I, J, and also K, which can, and C. We use this equation here, and this equation is known as dot multiplication, whereby you multiply by A multiplied by C. Instead of using a cross, you put a dot, and this one is given by that. And this one is brought about by having to resolve C in the direction of A. If you resolve C in the direction of A, we get C cos theta, and this is also called a scalar product, meaning that this one does not have direction. It has magnitude but does not have direction as such, and it's also called dot product. So for us to be able to get the angle between, you use this formula. So by using that formula, we have also A dot C. A dot C is, this is the A, that is our first vector, which is now A, and then we have now the B is here. When we multiply that, we shall be able to get our dot product as 9. That will be the dot product. This dot product has also, all of them has magnitude. For example, for the first one, the magnitude will be 5 squared plus 2 squared minus 1, that is plus 1 squared, square root, like this. This is the magnitude of the first vector, which is A. That is the magnitude, and the magnitude of C is given by that. You can remember about the Pythagoras theorem, guys, where we say A squared plus B squared is equals to C squared. So if you have two vectors, one being A, another one being B, you can have the magnitude of those two vectors is actually A squared plus B squared, which is now would give us C squared. That is what I would compare with when I see the magnitude here. So we get 14 as our magnitude for the second. So we fit them here. This is the magnitude of A, which is 30. The magnitude of C, which is 14. We are looking for cos theta. Already we have found the dot product. So we can divide 9 divided by both of the magnitude of A and B. This is cos theta. So when we say cos inverse theta of 0.43917 is actually, that 0.43917 comes from here. And finally we get our solution here, which is 63.94. So that is the angle between the two vectors, that is A and C. Then we come and find now the cross product. For the cross product, guys, we put a cross here. We say A times C, while for the dot we put a dot. And this is the formula that we use. We write here I, J, and K, and the first, that is the A vector. This is the A vector, and this is the C vector. So now we find what we call we call it determinant. This determinant is equivalent to the cross product of A multiplied by C. And when we get now determinant, this is what now the results we are going to get. Of course, it will be in terms of I, J, and K. So we get this as our cross product of A and C. So from there, guys, we go to another question here. Question 2, and it states, determine a unit vector perpendicular to vectors. You have this vector that and another vector that. For this one, guys, we use the cross product, because the cross product is where we are resolving these two vectors into perpendicular. When we resolve this in perpendicular to them, because these are in the same plane, then we resolve them to perpendicular direction. Then we use the cross product here, even as I had demonstrated in this question here above. So we find now the cross product by simply doing as we would do for determinant of this matrix, and this is what we get. From there, guys, because we are also looking at, it's supposed to be a unit vector, so we would have to divide by the magnitude of that. This is the magnitude, and the magnitude now will come to square root of 1976. That is the square root. And so, guys, from there we can now divide this by that. So when we divide now, we will get this divided by that. This is the magnitude, and this is the vector now we are having. But because we require unit vector, we would have to divide by that. Remember that unit vector, the unit represent sort of like 1. This is like you are told that maybe, let me give an example, that 20 oranges costs maybe 100 shillings. What about the cost of 1 oranges? So you have to divide the total costs. You divide by the number of oranges, so that now you can be able now to get the total cost. So for this one, you can divide by the magnitude to get the unit vector. That is the unit vector of magnitude, I would say 1. So this is now our solution for us. And then you can now divide this into different fractions, and then when you do that, you'll get that. So that is the unit vector. From there, guys, we come to yet another question here, and this will be our final question for this lesson. And the question states, given the vector, that is the vector, and another vector here, determine a unit vector perpendicular to A and B, and then the angle between A and B. So we do it the same way we have done the first one, guys. First of all, we cross product. We cross product of A multiplied by B. That is A cross B. For A cross B, we do it like this. So that now this one is A cross B. A cross B now is going to give us this as our vector. Then we would have, for unit vector, we would have to look for the magnitude of that vector when it has already been crossed. So that now we come and divide, just as we have done the former one, we come and divide. And then from there, guys, we come to the angle between A and B. For the angle between A and B, we just do as we did formerly, where we had this equation A dot B equals to magnitude A magnitude B, and you multiply magnitude A and magnitude B by cos theta. A dot B will give us -8. And then the magnitude of A is 14, because when you go to A, we actually, that square for the I, the value, the coefficient of I, we square the coefficient of J, we square the coefficient of K, without minding the sign, because once you square a number, even when it is negative, it will become a positive. And then you find the square root. And then you get here 14, square root of 14 and square root of 29. After you get that, that is being the magnitude, now you can come and fix your values here. You have -8 as A dot B, and you have these values as your magnitude of A and magnitude of B, and then you are left with the cos theta. Then we can go the same way we did for the first one and be able to get our theta, and the theta will be this value. So guys, thank you for listening to me. We continue next time.